Very warm welcome everyone to this first webinar in the series of Manufacturing 4.0 NTCC. I really would like to say a few welcoming words to people overseas, even Claudia all the way from the Netherlands, Dave, Ruben, Alco, wherever you are in the world. Thank you very much for joining us this afternoon. And this is the kickoff of many interactive webinars, hybrid, but also live events with company visits. Because remember, we have sent out a questionnaire to the manufacturing group members to ask for feedback. And the feedback was that we would like to hear more on certain topics. And we also would like to continue visiting certain member companies and share knowledge. Well, that's what we're actually doing today. And what will you be hearing today? Well, you will hear everything about industrial Internet of Things and also augmented reality. I know we all hear these terms and we read about these terms in newspapers, in blogs, etc. But what are they really meaning to you in the manufacturing industry? Well, who better than our friends from ZI Argus can explain these in more detail? And as I mentioned, this is our first hybrid event. That means we are in a live location at ZI Argus office. So I will now take you to the meeting room, which is not so far away from here. So I will now switch off this particular camera and please follow me.
So welcome back again, and welcome to the ZI Argus office here in Bangkok. And as I mentioned, this is a hybrid event, so I hope you can all see and also hear me. And when we entered this office this afternoon, we saw this award, and this was given last year during the Game Changers Awards dinner to ZI Argus as the winner of the category 4.0, Industry 4.0. So again, what a better place to start this series of the NTCC Manufacturing Group. And thanks again, board member Martijn Smit, who initiated this. So if you would like to follow me, we will go straight into the meeting room and say a few welcoming words to Frank van Baal, but also to Rick van der Meijden, who are both co-founding partners of ZI Argus here in Thailand. Hello, gentlemen.
What a nice surprise to see you here. Welcome. Welcome at the ZI Argus office, Virginia. So what can we do for you today?
Well, as we have discussed amongst our community, it would be great if you are willing to share your knowledge, also of you, and maybe your colleague can participate in the audience here in the room, about the topic of today, which is Industrial Internet of Things and augmented reality. Now, for me, being not really a technical expert, these mean futuristic, these means things I have no clue about. I know you both do, and I know this is part of the trend, and maybe not for the future, but already happening from what I understand from you. So if you're both willing to share that with us and the community, that would be fantastic.
That would be our pleasure, Hans. We are very happy to lift a little tip of the veil if it comes to the industrial Internet of Things and augmented reality. So what we have done is we prepared a small slideshow to give some overall information. We try to make it not too technical, so everybody can properly understand what this is all about. And after that, we're more than happy to engage in a question-answer session to answer any questions that would be out there. So
great.
Maybe if you
I will show
introduce people in the room, then I'll set up the presentation.
As we mentioned, this is a hybrid event. That means we are at a physical location with physical people. Jos, you come all the way from Chiang Mai. We know you from bicycle tours in great destination Chiang Mai, but we know you have a manufacturing production background. So thank you for joining us today as well. Our member Bernard Colin as well. Thank you very much, Safecoms, for joining and participating. Conrad, colleague from the gentlemen of ZI Argus, so welcome of course. And Martijn Smit, already introduced as the board member, initiated this Manufacturing 4.0 series. And Frank, if you are ready for the presentation, we would like to give you back the word. And best of luck. And audience, if you have questions, please use the Q&A functionality. We already received quite interesting questions, but if you have some burning question, please send them to us. And in about 25 minutes, we'll come back to that. We will now give Frank the floor.
Thank you very much, Hans. I'll talk to you after this session. Thank you. All right, I'm sharing my screen at the moment. I hope that that everybody can see this. Basically, Industry 4.0, smart manufacturing, IIoT, augmented reality, all a lot of big words, of course, and words that raise a lot of questions with people in general. As Hans already said, quite futuristic at times. So we try to slowly by slowly dig in what this is all about and give you a proper idea so that you know what we are talking about if we talk about these things. In order to look at Industry 4.0, let's first talk about the whole industrial revolution that we have seen. Actually, this is ongoing already since about 250 years, and it basically all started out in the early days, in the end of 1700, where basically we can call this Industry 1.0. The steam engine was invented, and this actually allowed us to manufacture now with different type of power than just human or animal power. And of course, because of this, production started to step up. Then there was about 100 years later, there was another step, which we call Industry 2.0, where basically we started to switch over into mass production assembly lines. Electricity came around, which of course massively changed the way we produce and the way we manufacture. Throughputs went up incredibly. From there, basically another 100 years later, we started to automate, where computer systems came in, electronics, and all sorts of different automation. And this led basically to the factories as we see them nowadays, especially the large ones with big automated control rooms, using programmable logic controllers, distributed control systems, all sorts of computer and IT systems to visualize the process and allow the operator to interact with the manufacturing process or the production process. And now, basically since the last couple of years, we have come to a new era, which we labeled Industry 4.0. And Industry 4.0 is a complete new era in which you find robotics, highly connected systems, intelligent systems, artificial intelligence, machine learning, all these kind of things, which all come together to allow smart manufacturing. So if we look at smart manufacturing, how can we achieve this in the context of Industry 4.0? Then basically it is through connected machines and connected equipment. It is through data collection and analysis of this data. It is about intelligent decision making, either locally or somewhere up in the cloud. Algorithms like artificial intelligence, machine learning are being used. And then after that, feedback to management operators, machines and equipment to basically improve and make our manufacturing systems more efficient. So in summary, smart manufacturing is all about connectivity. It is about data, and I can repeat this many times, data, data, data. This is the big thing about Industry 4.0, because this data will allow us basically to make intelligent decisions and to optimize. It is about monitoring, optimization, controlling, and of course also about automation of your manufacturing and process plant. Before we step into the industrial Internet of Things, I first wanted to talk about the Internet of Things itself, so IoT. This is something that we all know quite well nowadays, especially in the last 5 years. This has taken a massive step forward, in which we have so many devices now that are totally connected. If we talk about all sorts of systems to run your home for lights, air conditioners, heaters, even though we don't use that much here in Asia, CCTV cameras, security locks, well, you name it. There are so many different types of devices nowadays that sit somewhere in your home or in your office, have a wireless connection, and then through the internet are connected to some sort of a server data is being processed, and then on your app, you will get information of your device, or you have the ability basically to control your device. So switch on or switch off your air conditioner, switch off or on your lights, etc. At the moment, we already see that there's about 50 billion devices connected to the internet nowadays. And this is something that will only grow in the future. Now from IoT, there's a smaller brother, which we call the Industrial Internet of Things, IIoT. And I like to start actually with a small introductory video that gives you a little bit of an idea there what the Industrial Internet of Things does.
This is Jim. He is a manufacturer and owns a manufacturing plant. His plant has many things at one place, such as a supply chain and chain in the back office. All these things generate lots and lots of data, like transactional data, ERP data, CRM data, and public data. These are all the things together which empower and enable his employees to connect with customers and business partners. Now, even though Jim's factory looks well equipped, he still faces several challenges. During the production process, machines stop working frequently without any notice. Or sometimes the control system gets many errors at the time of product manufacturing. Even when Jim gets a lot of data, he cannot use it to predict the outcomes he wants. So, what could be the solution for Jim's problems? SoftWeb's IoT solutions are the best option for Jim to overcome these challenges. Whether it's a machine failure, problems in control systems, or getting accurate results from the data. Let's see how these IoT solutions can help Jim and his team. The Internet of Things, IoT, starts with the things installed in the manufacturing plant, the things that matter most to his business. The first step is adding sensors throughout the factory. In this production unit, IoT systems can help in monitoring production flow in real time to eliminate waste and unnecessary work in inventory production with the help of the sensors installed in the conveyor belt. All the data gathered by the sensors is sent to the cloud for analysis and creating predictive models. Not only this, but it will help engineers in implementing condition-based maintenance alerts to eliminate machine downtime and increase output by predicting machine failure. IoT can also help management to manage machines remotely, knowing temperature limits and other settings to save energy and reduce costs. With the collected data from sensors, operations managers can see their production line status and recommend adjustments to manage operational costs using data visualization tools. The R&D department can get insights from the usage patterns of multiple clients and track their equipment failure, enabling Jim's company to re-engineer products for better performance. On the other side, his field service management can identify when to deploy the right resources for predictive maintenance to minimize equipment failures and reduce service costs. With all these solutions, Jim can now tap into data with IoT dashboards and uncover actionable intelligence. He can also modernize how he does his business. IoT is a combination of sensors, cloud infrastructure, data analytics, and visualizations that helps you create a smart manufacturing unit. To know more about how we can
So I think that introductory video gave quite some good information on what IIoT actually is in a manufacturing plant. So as you saw in the video, in industrial applications, we talk about the Industrial Internet of Things, not so much about the Internet of Things. And this basically means that all equipment in an industrial facility is connected and has the ability to send data. This data, of course, can give very valuable insight in the real-time manufacturing process. Now, this data is stored in local or cloud databases, and then it's analyzed by intelligent software, artificial intelligence, machine learning, looking for ways to improve productivity of the manufacturing plant. Once that software basically did the trick, optimization strategies are then being presented through dashboards or through alarms or through direct messages to the management, to operators, and in some cases directly back to automatic equipment. Where do we find IIoT-based smart manufacturing systems? Basically on level of energy saving, for instance, maintenance optimization, improvement of OEE, downtime improvement, production planning and resource optimization. Quite a large variety of areas where basically a company can improve its bottom line. If you look at a little bit on the right, I don't know if that can be seen properly by everybody, but I like this pyramid which I put down there, which shows you the things at the factory floor, which are all the transmitters, sensors, actuators, all the equipment that communicate through networks and control devices to the IIoT platform, where basically the data is stored, and then the systems on top, they optimize and they use this data. So again, in the industrial Internet of Things, it's all about data, getting the right data from the manufacturing process floor up to systems who can analyze and make proper decisions. So as said earlier, smart manufacturing using IIoT implies the use of these connected devices, data handling, and all these software algorithms. IIoT is a solution. It's not a product. This is something that people often get confused about. They think IIoT is a product that you plug in and it optimizes your production or your manufacturing. That is not the case. It's a solution which needs to be particularly customized for every customer and every particular type of application. A big advantage of IIoT systems over traditional process control systems is that they can be implemented very fast, relatively inexpensive, and after a successful first pilot can be scaled up. So there is usually no need for real large investments to start a pilot. There can be a test case done on a small budget, and when the returns are there, we can scale it up. IIoT implementations are usually considered to solve particular business problems, obviously, but also to get insight in technology problems. So breakdowns, low efficiency rates of production lines, but also to solve planning and management problems. Make sure that the right kind of human resources are assigned to lines, that the assets, which are usually quite expensive, are being utilized in a proper way. So if you talk about IIoT, is this about automation? No, it's a step ahead of automation, basically. In the next slide, I like to show a little video, which I think is a nice example of how a smart manufacturing system can work in a plant, also with some additional information on how these systems are then connected to the devices. Just bear with me for a second. There we go.
What if the next big thing wasn't a big thing at all? What if it's a lot of little things all waking up? Your business is part of a global phenomenon called the Internet of Things, connecting people, products, and communities all across the globe.
From manufacturing, critical public utilities, to the shipping of goods.
Smart technology has ushered in a new era for the industrial sector.
With Splunk, adopting the revolution of the growing number of internet-connected devices and sensors is easy.
Splunk provides a transformative, data-driven approach that shifts your business lens from reactive to predictive and preventive industrial operations.
How does Splunk make this possible?
Splunk lets you use machine data generated from industrial control systems, SCADA systems, operational technology systems, sensor data, and human data to search and analyze information across your entire environment. With all your data across diverse sources, Splunk makes it easy to monitor and analyze issues, find trends, and detect anomalies so you can fix issues in real time.
Splunk shifts root cause analysis into the hands of the people that need it most, the engineers on the factory floor.
Create asset hierarchies on your industrial assets create interactive dashboards, and set personalized alerts with a couple of clicks.
Splunk's robust platform has machine learning and AI capabilities built in, so you can predict and prevent imminent outages without affecting production downtime. Splunk's real-time monitoring and predictive analytics help drive plant performance, improve product quality, and reduce equipment downtime.
The IoT revolution is here. Join millions of users around the world who are rethinking the future of industrial operations with machine data and Splunk.
So this was the first part in which we covered a high-level overview of the Industrial Internet of Things and what it actually does. Like I said, we tried not to go into too much technical detail, but if there are any particular technical questions going forward, please feel free to ask. The second part that we wanted to talk about is augmented reality, which is something that becomes more and more interesting. Most people know this out of the whole gaming environment, where you have these typical augmented reality systems that are being used for online computer games. But also now more and more we see augmented reality appear in the support of factories, training of operators, assisting operators. And basically the way this works is that it's a highly visual interactive method that allows you to provide information between an expert user who is somewhere remote, somewhere in the factory field. Augmented reality offers a very good way to create and deliver easy work instructions to operators by having digital content which is put on a real world work environment. And we see a little example of that on the bottom right of the screen, where we see an operator holding an iPad, looking at, in this case, a motor, and then the screen is populated with all sorts of information. And the expert user who's connected to this can basically draw instructions that can be seen by the operator. In the industry, augmented reality is used to deliver critical information to operators and other frontline workers. It enables you fast expert knowledge transfer, and it increases efficiency in support and real-time expert guidance. In cases you have problems with a large machine that you have somewhere in your manufacturing plant, and there is a problem, it's of course much easier if somebody can dial in, help your local staff solve the problem rather than flying people in from overseas. This is something, especially now in the current COVID times, which is obviously more and more important. So how does this actually work? It is what you call live over-the-shoulder collaboration. So there is somebody on a host system somewhere outside of the factory who connects with somebody who's in the factory. You can see this here on the right. Now the operator or the technician walks around, in this case with an iPad, and looks around the conveyor belt here, and there seems to be some problem. The expert user now gives an indication of certain things that need to be done and operations that need to be performed by just drawing basically on his screen. In that way, you have a very easy interaction between both the operator, technician, and the expert user. So it's a combination of live video, which is laid over on the real life video. Also, after particular sessions, there are summaries that can be used. So it's a very good way not only to solve problems, but also to instruct operators and technicians on how to solve particular problems in the future. So this is a little bit of an overview. So you could have an expert factory operator somewhere in a factory who basically supports multiple factories that are either on the same industrial estate or could be all over the country. He basically connects directly with an operator and then helps them solve problems. Or you would have an expert operator somewhere abroad who does the same thing. What is augmented reality mostly used for? Of course, the first thing is always all about cost. One big thing is to reduce operational costs, where you can lower the costs for experts flying in and coming to your site. It reduces safety-related incidents, of course, and then decreases downtime because you can more fast service. It also accelerates the training of your workforce. It improves their efficiency, and in the end of the day, if you are a service company, it can increase customer satisfaction. Like for us as ZI Argus, we of course service a lot of different customers. Time is always money. If one of the systems that we have implemented has a problem, or there is a problem somewhere in the factory, customers don't like the fact that you have to drive 2 or 3 hours to the customer site in order to solve their problem. And this is a way to speed these kind of things up. I have selected another video which comes on the next slide, which I think will give you an excellent idea of what I all just been talking about and how this augmented reality works in practice.
Digital transformation should empower your people. Today, a high-performance workforce requires extensive training programs, equipment maintenance, travel budgets, and support systems. Yet, the traditional means of sharing expertise are inefficient and time-consuming. Now we've created a new way to tackle these business requirements. This is Vuforia Chalk, an easy-to-use, powerful support tool that allows your workforce to collaborate in real time, anywhere. Chalk enables your workforce to connect for support or training. First, employees can share a live view of their workspace with an expert or coworker.
The waste valve here. Now that that's closed, you can turn on your surface wash valve, which is here.
Okay, got it. Both people can draw on the world and work together as if they are together. And thanks to Vuforia augmented reality technology, your annotations stick exactly where they're drawn, even when you move around as you work. In fact, you can pause the live view to draw easy-to-follow, multi-step instructions. With Chalk, simple instructions help you solve complex problems quickly and effectively. Chalk works on mobile devices, meaning your most experienced minds are accessible anytime, anywhere.
And then you want to open either one of these 2 motor meters here.
Having your best minds on the job remotely means solving the problem right the first time, reducing equipment downtime, and improving your bottom line. Chalk is ideal for service and training, and for other forms of collaboration too.
Okay, and lower the tongue, and let's lose this eyelid.
It's easy for your team to work together or give feedback from almost anywhere in the world, saving you time and money.
You did a great job your first time there. Thank you.
Accuracy, efficiency, collaboration. Chalk brings your workforce together with simple, intuitive tools they love to use. Vuforia Chalk. See it, solve it together.
Well, this was our high-level overview of both the industrial Internet of Things and augmented reality. It is quite difficult to cram 2 such big subjects in only a half an hour as an introduction. But I hope that this actually will start the conversation now, and that we will have some interesting questions in the question and answer session. So back to you, Hans.
Well, thank you very much for this update, Frank, and very enlightening. And for me, like I said earlier, not very technically underlaid, impressive. And I see there's much more to share and much more to communicate about this interesting topic, basically topics. And as mentioned earlier, we already have received a few questions. So the first question for you, Frank, or Rick, whoever in the audience, what would you say are the main advantages of collecting and analyzing data through an IIoT system? You mentioned the word data, data, data. What is the importance and the main advantage of collecting so much data?
Well, the main advantage of using an IIoT system is that it can be implemented really fast. So if you look at the traditional ways in which we always have collected data and tried to do optimizations, it was basically through control systems, if they were already in place at a customer. And in case there were no control systems, obviously this was often a manual effort. But with IIoT systems, you have highly intelligent sensors, for instance, that can be implemented very quickly at a customer site. And therefore, you can get very quick results. So low cost, quick results, and easy scalability. Those are the big advantages of IIoT over the traditional methods.
Yeah, and I think another aspect is actually correlation of data, because in many, let's say, traditional system, a lot of data is available, but it's very difficult to see the correlation between data that comes from various systems. So in a big manufacturing plant, you often have cause and effect. So you might have a problem somewhere early on in your production process that gives a problem later on. And if you capture data across the entire manufacturing process into a single system, it becomes much easier to understand the correlation.
Great, thank you for highlighting this also, Rick. Another question, and I tie this in with a question which just came in by Alco as well. In your experience, what would be the #1 reason for companies to install this IIoT system, and how does the journey start, basically?
Well, the #1 reason is always efficiency improvement. There are, of course, customers who install for a different reason, but at the end of the day, it always turns down to efficiency improvement and improving the bottom line, being more flexible, being more able to respond to market demands. So that is, I would say, the main reason that customers install it. What was the second part of your question again?
Second part is actually a question from Alco. Now, let's say the manufacturing wants to apply this system. How should they start this journey?
The journey is mostly quite simple. It's basically by starting a pilot. So identify a problem and then have a small pilot, which basically proves the power of the system and the returns the insights and the returns that you get through these kind of systems.
I hope, Alco, this is a clear enough answer for you. Otherwise, I know you have short lines with Frank. I'm sure this will be highlighted further. Another question, if I may. I know that ZI Argus is involved in implementation of the smart manufacturing system throughout the APAC region already for a while, and you're a real driver for technology and innovation. But how do you select the right technology which then is best suited for a particular customer? So basically, how do you customize the choices of certain technology?
Yeah, this obviously depends very much on the type of customer that you are dealing with. If we talk about large customers, often they already have a certain amount of smart systems, control systems in their plants. So they're basically standardized on particular type of products. As ZI Argus, we basically are an independent systems integrator. So that means that we work with all the large brands out there in the market, and we actually bring that all together into a smart solution for the customer itself. In case we talk about smaller customers who don't have very high levels of automation yet, or not a particular preference for a brand, then we also have our own systems that we implement. And that is, of course, where we won last year the NTCC award. That was our Symbiont. Our Symbiont is a highly developed system to address the needs of those kind of customers. So it very much depends on the customer type of applications, but we make a very good analysis on what does the customer have, where are the needs, and then we select the best product in the market that suits their needs.
That's very clear. Thank you for that, Frank. And since this is a hybrid event, we will try to open up the camera again, but I'm going to ask you another question, and I'll be joining you in the meeting room. Augmented reality, the second topic you addressed, has gained popularity over the last 2 years. on the back of products like Oculus Rift and Microsoft HoloLens. But I can also imagine the current COVID-19 times have really accelerated the implementation of this technology. Frank, Rick, do you witness this trend as well?
Yeah, that is definitely the case. Of course, one of the big problems that we now have in these COVID days is the fact that there are no international flights. So if you have a manufacturing plant and you have a lot of specialized equipment which needs to be serviced or needs to be addressed by technicians that live outside of Thailand, then you have quite a big problem. These experts often do not have the ability to fly in. And because of this, you need to find other ways of cooperating and solving these problems. And that's where augmented reality actually steps in quite nicely. And we see a lot of customers who actually now open up to these kind of technologies rather than, of course, in the past. In the past, they would simply fly people in, but now they install these kind of systems to address their needs.
Thank you.
We already see it actually being used for commissioning as well. So one of our customers has purchased equipment out of the UK mid of last year. This equipment is meanwhile installed, and normally a specialist from the UK would fly in to commission this equipment. It's now, of course, not possible, so they're using actually augmented reality right this week as we speak to get this equipment commissioned.
Great examples. Thank you for highlighting and sharing that. Like I said, this is a hybrid event. There might be some questions from the audience here present. Looking, for example, at you, Martijn, do you have a question?
Yes, I have one question. So it already linked into a question that was posed earlier, but how do you implement and integrate all these technologies in your existing processes?
Well, it's as I said, it depends on the situation of the customer. But if a customer already has a certain amount of, let's say, control systems, what you need to look for is how can you get the data out of these systems, which means they should have some level or some ability of communication. If that's available and there are easy software tools then to connect to these systems, you can get the data out. If that's not available or the processes are highly critical, then what you often see is that the installation of smart sensors takes place, who then gather the data and bring this data together into a database which can sit anywhere, which is then being used for analysis and for the whole, let's say, smart system that you put on top of it. So yeah, depending on the customer, basically, we try to reuse as much as possible, of course, equipment which is already there in order to keep implementation costs low of these kind of systems. Anything you'd like to add?
Yeah, it's also often about adding, let's say, certain information which is, let's say, relevant to what is going on, but which is not necessarily captured in current control systems. A very good example would be, let's say, an industrial refrigeration system, of which the energy consumption, of course, very much depends on the environmental conditions. What is the current ambient temperature? What is the humidity? And bringing those kind of data into that system. It's once again about this correlation, so that you better understand what's going on. And this also sometimes is human input. As long as you have operators in your manufacturing plant that are doing things by hand, even if it's only, let's say, refilling packaging material or something like that. If something goes wrong, you need the input basically from these people to understand an event that just happened. A packaging machine, fully automatic, stops once its magazine with packaging material is empty. But then, okay, that's the reason its own right why the machine stopped. But why did this happen? So you have to reach out to this operator to understand, was there a quality problem? The forklift driver took a nap and didn't deliver the material to the line. So it's also about finding those additional puzzle pieces to totally understand what's going on in the manufacturing plant.
Okay, so the human factor remains still.
As long as you have people in a factory, that human factor still plays a role. Yeah.
Thank God it's not only all about technology, but the HR element is still important. Talking HR, are there any more human questions in this group? question from you, Joost. Bernard, do you have something perhaps you would like to ask?
I would add one little detail. When you look at something like this, one thing comes to mind is the security of the system. And there are two things that you need to be aware of. Is that when you deploy IIoT, you have two aspects of the data that you need to look at. The first aspect is the confidentiality of the data, and we're looking at session client servers that are identified, so the communication cannot escape the server that you design and cannot be captured by anyone else outside. This is encrypted communication anyway, so even if someone could sniff on it, they could not read what it is. The second one is the integrity of the data, where when you work on a system like that, especially in industrial environment, we talk about the relation between the noise level and the level of your data. You talk about sensors that affect the transport information, and you have to have a mechanism to analyze the value of the signal that you capture and have a system error free. And these mechanisms are based on the communication system, naming LoRa system, which is long range system that has an extremely high noise ratio capability. So you don't get your data lost, and it doesn't interfere with the noisy environment in the industry. So you have a perfect system to react with your environment.
I assume you acknowledge what Bernard mentioned.
Yeah,
We can explain it to you later.
Okay.
Largely, I think it's also important to understand that most of these modern sensors are also intelligent in their own right. So an old-fashioned temperature sensor would just send one signal, which was a measurement of that actual temperature. But if there would be something wrong with the probe, you wouldn't find out until somebody would calibrate it. Modern intelligent sensors actually have logic built into them, and they will report their health status. So a sensor is also able to detect itself that it has a fault. So this further adds to the reliability of the information that is received from the process.
All right, great. I just checked the computer on my desk over there whether there are any new questions, but I didn't see any new question coming in. So thank you all for raising this question. Thank you to both gentlemen for answering them and enlightening us. Also you, Bernard, as well. A big thank you, of course, to the audience, the viewers who are joining us from wherever you are. I see a few are zooming in from the Netherlands. A very good morning there, and some other countries as well. So I hope this has contributed to your knowledge, which you already have, and further added knowledge as well. As mentioned before, we will continue with these seminars, webinars, and visits, so stay tuned. I will explain a little bit later the upcoming one next Thursday, but maybe this is a good moment to say a thank you to our guest speakers, both Frank and Rick. And if I may kindly ask Martijn, as the representative of the NCC board, to give them a token of our appreciation for this wonderful hybrid webinar and all your knowledge sharing with us.
Yes. So again, thank you very much for kicking off our Industry 4.0 series and setting, I might say, an excellent standard, with no pressure for the others also going to contribute. I learned a lot today because I'm not an expert in this field. In my industry, we don't really use it at the moment. And I hope for the viewers that they also learn from this basically introduction into this field. So thank you again for CI Argus hosting it, and for both Frank and Rick for presenting us and making us a little bit wiser today. Okay. Thank you very much. I don't know who wants what. Maybe we can have a fight over it. But thank you again. Thank you very much.
All right.
Thank you very much.
Easy alcohol water.
And of course, also a great thank to my colleagues who are, let's say, running the back office. Convin is holding the camera right now. We're looking into Kunflo and Kunedi. This is always a team effort. So thank you to the colleagues of the NCC office. As I just mentioned, stay tuned and sign up for next week's event. Next week on the 20th of August, we have the friends of Royal Haskoning, DHV, Ruud Krook. I think you're zooming in as well, so hi Ruud in Singapore. So next week will be all about predictive simulation and digital twin. I guess a very interesting topic for you as the audience, and perhaps for you as well to zoom in as well. We have more upcoming events. Mark your diaries, 10th of September, a visit and presentation by Kirloskar. Remco, I know you're there. Thank you for that. I think we're going to sign off KUKA Robotics on the 1st of October. And I believe Upbeat, Harry, I think you're zooming in as well. We will visit you on the 15th of October. So a lot of happening, a lot of excitement in the manufacturing group of the NCC. Martijn, thank you again for taking that initiative, and a nice warm bye-bye to all the viewers and to you here in the audience. Thank you again for joining us. And stay tuned and hope to see you next week at the other Manufacturing 4.0 webinar. Have a nice evening, everyone. Bye.
Bye-bye.
Bye-bye.